Hi, you're watching Analog Output. I'm Rich Holmes, and it is time now to stop talking about ribbon controllers and start building. Okay, that took way too long, but it's done. I soldered some headers onto the Arduino Mini, and these are right angle male headers, and that enables me to plug the Arduino into the USB interface, making sure that we get the proper orientation, which is that way, and then plug this into USB over here, plugging this in to there, and we got a light there, and you can see this LED is blinking slowly. The reason the LED is blinking slowly is because I have already done this, and I uploaded a sketch that tells it to blink the LED slowly. So just to prove to you I'm not lying, we're going to change it to blinking the LED faster. Alright, so go over to the Arduino site. Right there, on the Arduino site, we've got a sketch here. I've changed the blink rate down there to 100 instead of 1,000, so it should blink something like 10 times a second. And what we have to do is make sure we've got the proper setup up here. So we go up here and we're telling it, yes, we've got, yes, we've got an Arduino Pro or Pro Mini. But the thing that took me about an hour to figure out, well, one of the things that took me, I've made a few other mistakes too, but one of the things that took me a while to figure out was I had to select the proper processor here. And once I did that, then I could go up here, click the button, look down here, and watch as it says, "You are done. Thank you." And if I now look at my LED, what's my LED doing? It's blinking fast. All right. Yeah, the ABR is programmed. The Arduino 5-volt board is being programmed by a 3.3 volt interface, which is good. And so we can upload our software, and so we can use the Arduino Mini, and so we can forge ahead. Yes. So next thing to do is to give it some more headers. Downward pointing headers. All right. So that's the Arduino setup. And next we can start putting in other parts. All right, now for the input jack, I got this thing. This is from made by SparkFun. It's a breakout board for a 3.5 millimeter audio jack. I'm going to use this for the input, and even though I'm only using 2 conductors, since we're not connecting to the far end of the soft pot, still going to use a stereo jack with 3 conductors, just in case it turns out ever to be needed. And then solder in a header here, and then this can just plug into the proto board. All right. This stuff here, which looks just like silly putty, is in fact silly putty. And it works pretty well for holding stuff down when you're soldering. Forgot where I learned that trick, but it's a good one. I've got one of those helping hands things, which is sometimes useful too, but more often than not, the silly putty. Works perfectly well and is easier to deal with. All right, output jacks. There's supposed to be 3 of them, but I'm just putting in 2 for now. So it'll be one of the control voltages and the gate, and the other control voltage we can, switch the jack around if I need to test that. But just start with that. And I don't have a breakout board for them. I'm just plugging them directly into the proto board, and got that plugged in there. Yeah, the claim is this should be everything. However, what I'm going to do is I'm going to look and see if I can find myself a potentiometer which will stand in for the soft pot initially, just so I don't have to mess around with the soft pot any more than I have to. It's kind of delicate. So I'm going to think about doing that. Right, which will substitute for that thing there. But I have to look for one. All right, next. Okay, so I think, I should check this over, but I think this is properly wired. All right, well, the next part I don't have on video. I connected up the USB to serial converter to the Arduino and connected a USB cable to the USB to serial converter and uploaded the software and started checking voltages on the outputs. And now the USB to serial converter is supplying the power for this thing, and it's only supplying 3.3 volts. So you're getting only a maximum of about 2/3 of the voltage you would get with a 5-volt supply. And then in addition to that, the potentiometer is only 10K, whereas the soft pot would be 20K ohms. So you're only getting half the span out of that. Given that the behavior of the first control voltage seemed kind of okay. It didn't go down to 0, but it did go up to about where you'd sort of expect it to be. But the second control voltage wasn't the same as the first. In fact, that one did go down to 0, but it came up to considerably less than the first one did. The gate output looked fine, going between 0 and 3.3 volts. So I was a little confused about those control voltages and figured I had some debugging to do. So I started looking at the code. Okay, turns out, looks like it's not a bug, it's a feature. If you look down here in the code here, you see where it calculates the value it's going to send to the DAC for one of the DACs and for the other DAC. One is called pitch valve counts and one is called filter valve counts, and they're not calculated the same way. Pitch valve counts has this offset of CV note bottom, which is set equal to 12 earlier on, and filter valve counts has this factor, this multiplying factor of keyboard track, which is set equal to 0.6 right up here. So this one has an offset respect to this one, and this one has a different scaling with respect to that one. So of course they're not the same, and in fact this 0.6 is kind of consistent with what we're seeing, and this 12 note offset is kind of consistent with what we're seeing. So I think this is all doing exactly what it's basically supposed to do, at least the way Audette wrote it. Me, I would like to have no offset, no CV note bottom, and no scaling factor. I would like these two values to be the same. So I'm going to edit this thing to make that happen, and then I think this is all working. Okay, well, we have some partial success here. So I've moved the proto board next to the synthesizer. I've removed the USB to serial converter that was powering it at 3.3 volts, and I've plugged in a hacked USB cable. I cut off the end of a USB cable and soldered on a couple of resistor legs so I could plug them into the proto board. So they're powering it now with 5 volts. I have not been very successful at getting this thing to gate with the gate trigger, gate signal. Then again, these jacks there are so shallow in the proto board holes that they tend to fall out as soon as you try to do anything with them, so that's not so good. Anyway, proceeding onward to the more sturdy of the 2 voltage control outputs, which, by the way, I've measured with the voltmeter, and the voltage control outputs are now both putting out the same thing, although maximum seems to be only about 1.7 volts, which is kind of low. It should be about 2.5. Maybe that's just a calibration thing that we need to deal with when we get the actual ribbon controller on. But does it do anything? Well, yes, and well, have a listen. Okay. I turn this up very, very slowly. You can hear the pitch rising. Okay. Trouble is, though, if I turn it fast, it's not going anywhere near continuously. It's as if the sampling speed is so slow that it's only getting a few samples per second, and it's jumping in between them. Okay, I did about 20 seconds worth of further thinking and realized, oh yeah, all those debug outputs that were being printed to the serial monitor, I never turned them off, so it's still trying to print to the serial port with nothing connected to the serial port. Of course that's going to slow it down. So I turned off the printouts by changing the various symbols like print text and print cal text and print CB text and so forth, changing them from 0 to 1. And now, if I turn on the synth and change the knob, it's smooth. We're getting there. Okay, so where do we stand? Well, I think we stand pretty well. The voltage range it's putting out is too small. That's probably just a matter of calibration, and we can take care of that when we've got the actual ribbon controller attached to it. The gate I'm a little puzzled about. I think it really is, well, maybe it's just a problem with the jack, or maybe I'm just overlooking something obvious, but you know, I know I'm sending 0 volts or 5 volts to the gate output, so it ought to be working or made to work without too much trouble. But I'm going to put that off until we're actually working with the actual ribbon and the soft pot and maybe some better jacks. But I do think, after all, I'm probably going to need a 5-volt USB to serial because I want to debug this thing So I need to look at the outputs that come over the USB to serial, and I want to debug it while it's running at 5 volts. So kind of need a 5 volt USB to serial, I think. So that's going to delay things a bit, but I can work on the actual physical ribbon in the meantime, and then start making some more progress. So that's where we're at right now. Tune in next time. Like it if you like it, and subscribe it if you want to subscribe to it. You'll hear about the next installment when it comes out. Thank you.